Hey everyone who woke up and came here at 9:20. I am Kurt Nelson, and I'm here to talk about the two types of building apps at scale. And I've done framework work and platform work and build tooling work at both Uber and Google, so I'm kind of summarizing a lot of the process that we use at both those companies to ensure app quality is good across the board. So, anyone in here consider their work being at scale, and specifically their mobile work? One, yeah. So I want to make people think more critically about the term at scale. I know it's often just thrown out, especially in job descriptions or by recruiters or by companies of, hey, we're at scale, but so often I find they're not necessarily doing mobile applications at scale. They might have a web app or a backend service that has millions of queries per second, but the mobile app is maybe even a second thought. And so there's kind of different ways we can think about whether an app is at scale and whether you need to start thinking about some of these things. So backend and front-end engineers will generally talk about queries per second when they're discussing scale. And it is a decent metric for a API, of course, but maybe your mobile app doesn't hit the API every time. Maybe it hits the API a million times a day. Who knows? So I think we need some better metrics for mobile for talking about when we are operating in this way. And yeah, mobile apps can also be at scale in very different ways. Unlike a backend service where you're generally running a data center, microservices, you can vertically or horizontally scale in that data center. With mobile apps, we are shipping a binary to a user's device on the edge of the network and doing compute on that device. And we are not like a web app where you're just rendering views, often with an assumption of connectivity. We are performing devices on the edge of the network. And so the first metric I would use to decide that you are starting to hit some of these problems is either your monthly, weekly, or daily active users. Which metric you use is completely up to your use case. I know at Uber, we track daily active users because a whole lot of our users would be, especially drivers, for example, would be using the app every single day, whereas maybe you are the Wikipedia app and people launch it, generally not more than once a week. And so graph these and see which one kind of is stable versus if your dailies are really jumpy, it's probably not a useful metric to use. The other thing to think about is, and this is something I don't have an answer for, is how big is big in this case of the amount of users in the amount of active users. Are you talking thousands, hundred thousands, millions, or billions? At Google, a lot of the big Android apps, of course, are in the billions of daily active users. Uber, pretty high in the millions. But maybe for you, your type of app, if it's especially an enterprise app or something deployed on a physical device to a consumer's house or something, maybe just hundreds of thousands is a whole lot of users for you and something you should think about. The other metric I like to use in the same vein on the user side of whether you are going to start running into these scaling problems is the device diversity. And I kind of made this term up. And it is specifically the idea that mobile software, especially Android, runs very differently on different devices. We have a huge variety of operating systems, devices, form factors, countries, languages, and all that can add to your complexity and cause some of your scaling problems, even if you don't have necessarily, that millions of daily active users number. So this is kind of, I would say, these two numbers are things you can use to track your growth on the user count side. Then what I'm considering the second type of being at scale is how many developers do you have working on your mobile app? At Uber, we had an Android monorepo, so all the Android apps at Uber, which is driver, rider, eats, the app that sits in the restaurant to take your orders, some onboarding apps, some weird admin apps. They were all in one monorepo that had 100 to 200 mobile engineers working in that one monorepo. And this sets you up for a whole nother set of problems when building your apps. Another interesting thing here versus backend is no one, as far as I know, has ever tried to do microservices for an Android app. You might have some modularization within your app, but you're generally building one monolithic app. And you might have, even at a smaller shop, tens of developers all working in that one app. And then there's also kind of the rise of what people are calling the super app, where one of the search engines over in China was early to do this, where they said, oh, we have our suite of 5 or 6 apps right now, but we want to do one app that unifies all these services and has all that code in it. And that adds to this type of complexity and scaling problems of having all these developers working in exactly one map. And then Google, so Google there's what's called Google 3, and you can look up there's white papers on it, and it is the main monorepo at Google that has all, not just Android apps, iOS apps, backend, front end, almost everything except for Android itself, and then actually it's Android, Android X, Jetpack, the stuff that's over in Garrett. Pretty much everything else at Google, including the open source, is all in that one monorepo. And so when you're working in a situation like that, you're cutting across multiple apps, or even for a schema change for a protocol buffer that is shared between backend, Android, and iOS, you have to think about these things and have processes to deal with this, because you might be affecting hundreds or, at Google, thousands of developers. There's one legendary proto called the Google Web Search Proto. It's been around forever. It has thousands of fields, and it's kind of was the old proto that did anything search related, and it's kind of bundled in every app ever from Google. Changing that proto, of course, causes all kinds of fun things to happen in your CI and CD environment. So all this to say that scale is kind of a vague term on mobile. There's not a cut and dry QPS type of metric, or the amount of compute time you use. Compute time, I feel like, is something we don't ever really even think about over on mobile. And so yeah, there's not one size fit all for this. So that's kind of my point, is that it's all kind of, pick and choose and feel where you are on these different metrics and different directions that you can go, and pick what works well for you. So now I'm going to drill into more about active users and kind of how I define it. So another interesting thing about mobile versus other, especially web services, is that an app could just be sitting installed on someone's device and be not used, be force stopped, be paused is what I think it's called now in the newer versions of Android, or just flat out rarely used. And one example I like to use here is there's a whole suite of apps I have on my phone that I only use when I'm traveling. So, airline, hotel, rental car, certain navigation things. And those just sit on my phone, but I use them, maybe best case, pre-COVID, once a month. And so, am I an active user of those? How does that affect your metrics? And then the fun thing there is you can get these weird seasonal spikes in users where, around the holidays, everyone's traveling and is opening these apps, and you might suddenly be like, oh crap, we just shipped something right before the holiday and broke everyone. And one thing that we use to mitigate this at both Uber and Google is, especially over Christmas, because developers tend to be out, is a holiday code freeze. So if you say, hey, we're not going to be shipping new versions of the app in case of an emergency around the holidays, can kind of help you not get people stranded on Christmas Day, for example. I do also, though, expect these apps that I don't use that often to be usable and up to date when I do launch them. It's also frustrating if you launch one of these apps and it's like, hey, we have to do a 5-minute sync because you haven't used it in a month. So some other things to think about as far as defining an active user and counting these people and kind of figuring out whether you need to deal with scaling for the number of users is when and where are your users? Seasonal, geographically, time zone. Maybe your app's way more popular in one country than another. That can impact your load over the course of a day, 24-hour period. As I said, installations does not necessarily correlate to active users. And then The other big thing to think about is, are you on the App Store, or are you more of a biz dev-driven installation? Is this something that people are just going to download from the App Store, so you could suddenly go viral and get in news media or have some seasonal thing happen? Or is this the type of thing where it's, oh yeah, we're installed on a tablet on a wall somewhere, so we're not going to suddenly have 1,000 new tablets appear overnight? And the other metric I'm going to drill down into more is device diversity. And my summary of this is that every instance of your app that's running is basically unique and different in special Snowflake. I liken this back to when in early Web 2.0 we had Internet Explorer versions, we had Firefox versions, we had Chrome versions, OS, weird. You had to kind of cover the whole gamut if you wanted a truly compatible app. And yeah, over the years on Android, we've had all kinds of wacky devices. We had Google Glass, for example, which was kind of running Android apps, but kind of not. It was a fork of production ice cream sandwich that was always slightly out of date and had missing APIs and added APIs. So if you wanted to share code, you had to be aware of that. We had the whole honeycomb adventure, or I guess now we can call it, tablet part 1 of 3. We're now, I guess, on part 3 of tablets. We'll see if it sticks. Android Wear. Early Android Wear was severely fragmented, where devices would definitely get stuck on an old version. Hopefully this time around with the relaunch, it's going to not have that problem. Android TV, once again, like you have form factors, sizes, OEMs, OS versions, just this huge wide amount of devices that your APK could land on. And then, also, if you want to get more exciting, we can throw in here the whole Amazon Store Fire TV type experience where you might not even have the Play Store. And then, of course, there's more than physical form factor. You could have your OEM differences, such as tends to be Samsung, does something different. The battery optimizers from the OEM that can basically give you unexpected behavior. Language. So if you're running on devices in RTL markets, right to left, if you have users with screen readers, operating system version, just straight up old versions of your app floating out there. This definitely used to be worse back when a lot of people were sideloading all the time from the various APK websites. You could have someone installing the wrong native version of your app on their device. And then network connectivity. Not everyone has nice, shiny 5G all the time. And these are all things that can just add to this scaling problem of, as you add more users, you're going to run into more of these things, and you need to make sure at least that these aren't surprising you. You might say, hey, we know we don't support this, but it's better to know you don't support it and have your support staff or marketing staff aware than have someone suddenly be like, hey, I'm trying to use this offline and it doesn't work. I do feel like Compose is going to help with some of this, with just having reactive design, so you don't have to worry about all the sizing RTL type issues as much, but it's getting better. And then the whole other thing that you need to think about when you are about to have a bunch of users, or if you have a bunch of users, is what at Google they call next billion users, and there is a public website that has a bunch of resources around this. And this is where this gets real exciting is when you have your app running on devices that you physically cannot get in your country. Maybe you have someone somewhere in Asia who can mail it to you. Might take 3 weeks. That can be exciting if you have a bug that only repros on carriers or devices you've never heard of. There's a whole Android Go, which I think it sounds like it's kind of rolling back in. And then language. So if you get bug reports or Play Store reviews in a foreign language, that's a whole other thing you might have to deal with. Payment frameworks. So India and UPI come to mind, where you aren't going to use Google Pay in India. You're going to use the government-provided UPI. And then just making sure that your app can be used on little or no or intermittent connectivity. So these are all things as you add more users, you're going to run into. And as I said, it's not necessarily the number of users you have, but it's how many of these types of situations are you running into regularly is where you need to start thinking about handling your app being at scale. And my summary of my 2 metrics here is that device diversity correlates with an increase in your active users. So the more active users you have, probably the more weird devices you're going to run into. That's just kind of a fact of Android life. So in summary, the 2 scales that I'm going to talk about here are device count and developer count. What are the things you can do if you have a lot of devices? What are the things you can do if you have a lot of developers? And there are a few things that you could probably do if either one is an increasing number or you think is about to increase. So let's talk about those common practices that are useful in both cases. Basically, once your app is in production, non-trivial size, and starting to get some traction, product market fit type phase. Huge one is feature flags. So here on the right is a screenshot from Firebase, which is the nice free implementation of feature flags that can work across iOS and Android. If you're not familiar with feature flags, they allow toggling features in your code on and off easily without having to do any sort of update. So it's completely server powered. Some options even can do it in near real time or a push essentially. And this becomes important because you can turn things on and off without having to mess with the Play Store, push a binary, or wait for people to take up updates. And the gotcha is that you need to make sure you have these in place ahead of time. Your developers need to kind of anticipate the need for a feature flag. And the good way of doing this and getting these kind of in the spots where you need them is using them to guard incomplete code. So both Uber and Google very much encourage people, if their code was going to get merged in, it should always be behind a feature flag until it's launched. And this way, it's not appearing to the user until it is ready to do so. And another thing that often occurs is you rename your feature flag from when you were in development to when you're feature complete. That way you don't accidentally turn on a in development version on an old app for someone. And so you get this in place, you develop under one feature flag. That way you can let people try it, you can push it to certain users, get feedback, and then when you say, okay, we're ready to do the real production launch, you rename it to, my new feature real, and then start rolling that out to users. And one big advantage of this, even if you are not trying to, or you're not worried about being at scale and being able to kill features if they are crashing you, is that it's a good way to guard stuff for other developers, internal users at your own company, or you can have power users or beta groups that you're like, hey, we have a new thing, let's flip this on for you. And here's just kind of these slides are going to be online. That's just a screenshot of the standard remote config in Firebase. That's what I recommend people start with if you don't have an existing system. Both Uber and Google had home-rolled feature flag systems, which I feel like is unfortunately relatively common once you get to that size of a company. And there's, of course, quirks with the in-house ones. But yeah, Firebase is a good spot to start. So the benefits of feature flags, when you both either have a bunch of developers or a bunch of devices, is you can target kill switches. So you build your new feature. Good example, you have a new video editor in your image editing app at a company I used to work for. And we found that if you use a certain video filter on a good subset of devices that were missing a certain media codec, the app would just always crash 100% of the time. And there was nothing we could really do about it because it was just straight up missing a codec to process that type of file. So if they had a feature flag in place, we could have done a group of devices and our diverse device set. We'd say, okay, this class of devices, we want to turn off this feature flag so they cannot get in this bad position. We're going to just turn off this specific video filter for now at least, so that people aren't crashing themselves. So that's I'd say the biggest advantage of a feature flag is that if you have a crasher, you can just turn it off make it go away quickly, easily, and deal with it later and do an update later. And then the corollary to that is that it allows you to do a slower rollout of a new code path. So if you have your new feature and you aren't confident in it yet, especially across that whole device, the diverse device set, you can do an incremental rollout and say, hey, we're going to turn this flag on for like 5% of users and see what happens. You can look at your reports. Oops. You can look at your reports, see what's going on, and kind of control the story. This is also nice if you have PR people who want to do a very specific release date. You can go ahead and put it in the binary, make sure people have it installed on their phone, theoretically as far in advance as you want. And then when you hit that date, you can push this flag out and probably, depending on your system, in a matter of hours, have everyone using the new feature. Now, one thing that both Uber and Google had in their in-house feature flag systems is you could kind of say, this one, not super important, let it kind of roll out naturally, or, hey, this one we really need to flip right now, and it would actually send like a push payload silently to the app to say, hey, feature flag has changed. Please shut this off. You can also do purposely driven device-specific flags. So maybe you have a feature that only makes sense on phones or only makes sense on tablets, or you want to make sure that you aren't running certain code if they don't have a smartwatch. You can put that code behind the feature flag and then only turn it on for those specific users. The other fun where this happens on the having a lot of developers side is if you have a whole lot of people and maybe spread across time zones and something goes horribly awry and is broken and you're getting bug reports or someone's yelling at you in product and being like, hey, my whole thing's blowing up. Can you fix it? Or this is not working right. The quickest mitigation is often flipping a flag, even if it's not your own, is a nice thing. If you have it set up right, a developer can flip any other developer's flag off so that if they're asleep in a different time zone, you can mitigate it until everyone else has time to root cause it. This also helps with on-calls because if you get paged in the middle of the night, you go look at it, you're like, oh, that's a new feature that team rolled out. Let me just turn it off and go back to sleep. And that can be a very valid pattern for on-calls. So on top of this, another thing that is extremely useful is experimentation. And often experimentation is built on top of feature flags. It's kind of a special use case of your feature flags. And it tends to be an automated way to run your feature flags. So if you have your new feature that you have never deployed before, you set up an automation to say, I want it to day 1 go 5%, day 6 go 25%, and then eventually get up to 100%. And you fully automate it, and you hope it can just kind of go through its steps, and then it rolls out, and you're like, yay, my new thing launched, and you go put it on your next promo packet. And the nice thing is this can often be coupled to your analytics system. So you can say, as long as these things are not being impacted, keep doing that rollout of that feature flag. I would say this is essentially a business-driven feature flag. So you write your thing, you test it, you say you're ready to go, and then the business has some rules on what they expect to happen when this feature flag is rolled out. So you might monitor your revenue, your crash rate, both, the usage of the new feature. And this is often based on a flag. You don't necessarily have to base it on a flag. You could have some sort of other experiment. Maybe this experiment is purely server-side driven, and the app is just kind of reflecting that data, and you want to send the analytics back. The other feature of a good experimentation framework is that it helps make sure that you aren't crossing your experiments. So if I have an experiment running and someone else, and my coworker has an experiment running, and we both said we want 5% of users to be treatment group, and then 50% of users to be control group. The experiment system would make sure that we are doing separate treatment and controls for each of those two experiments. This way you have actually valid data, and you aren't sending someone 2 different treatment groups for your experiment. So you aren't doing a double experiment on one person, because that is going to mess with your analytics. And Another thing in a more advanced experimentation system is that it would plumb through to your back end. So you would, if I am put in the new experiment for the new car icon on the Uber app, the back end would know that and the app would know that. And so they could both do different behavior for that user who's been put in that new treatment group, and the analytics often unified across both. And so my summary of experimentation, for people who haven't not used it much, is it's a scalable way of doing user feedback. Instead of having to send a survey out and be like, hey, did the app crash? You run an experiment that's tied to the analytics around that with your new feature rollout, and you have nice data, and often these systems will give you actual statistics that then you can go crunch later. And it also ensures you have a quality product, because if something goes awry, the automated system will often, you can set it to say, roll back the experiment, go back to what we know works. And Firebase has built-in experiments, and one of the things that you can experiment on is remote config. Here in my example, I think I set it to, so yeah, you set your name of your experiment, your goal, so you can set a primary goal. Here I said estimated total revenue. Secondary goal, make sure you retain the users and don't crash them. And I said 5% of eligible users, and then variance, I said take this key and do these two different things to that key. Firebase also lets you do experiments on push notifications, so you can A/B test your text, for example, in the push you get. And then there's another one with the new in-app messaging where you can experiment on it. Okay, so let's pivot over to the other set of problems that you can have, or the specific set of problems you can have, which is we have a ton of developers on our team, and it's getting chaotic. So how many is many developers? Are you shipping more than one app? Are you in a monorepo? Is every time you upgrade a library, you don't know what's going to crash and where it's going to crash? So I know you go in, you upgrade Kotlin, and you're like, I hope this works. That might be a sign that you have a whole lot of developers working on one app. Step one is have a healthy engineering culture. These are kind of the same ideas that you would do for back-end or front-end engineering. Make sure that you communicate and you know what each other are doing. You have a SLA around code review, that code review is not sitting around forever, because then merging is going to be harder. Keep your tickets up to date. Treat your code at your company like it's open source, meaning that if I want to go fix a bug across the app in someone else's code, that's okay and encouraged. And make sure your on-call is healthy. So if you're on call and you don't have feature flags and you're expected to fix something in someone else's code, that's going to lead to problems. And do postmortem. So when you do have an outage and you end up crashing a whole lot of users in a certain country with a play services upgrade, which is something I've done, you do a postmortem of how was I able to crash all these writers in India for a couple hours? And then how can we not do that again? And kind of the summary of the engineering culture here when you have a lot of these developers is make sure that you aren't stepping on each other's work, and that if you do, you know you're stepping on it. And Firebase helps with this. It's free, it's valuable, it is kind of annoying to use when you have a whole lot of developers. It's not built for hundreds of developers to kind of all be in one Firebase console. You end up with just feature flags upon feature flags. You might mark a bug as resolved and no one else sees it, but it's better than nothing. So if you have a bunch of developers, hopefully you have someone who kind of owns these sections, your crash, your performance, and your release process. Hopefully there's like a program manager who kind of pokes at this stuff probably every day and looks for anything scary here. If you don't have someone who's assigned to do this, you might end up with scary crashes that no one notices until it's, a customer notices it. App distribution really helps when you have a whole lot of developers or big teams, because it gives you a way to push weird binaries that are maybe not committed but are production equivalent to QA or external QA. So instead of having to upload to the Play Store, you can do an app distribution link, and that QA team can get a like Play Store product. So if you have app splits, dynamic features, that all works via app distribution versus emailing someone an APK or AAB and then having them split it. And yeah, these are all things that, glancing at in Firebase after a new binary or release goes out is just, did anything go really wacky here? And this is, I found over the years that giving your product or program managers access to this type of data, whether it's Firebase or an internal tool, kind of can make them just happy for free. Because they can go in here and be like, oh, what's going on? And then at a minimum, it generally prevents them from asking, sending you a Slack and being like, hey, how's the new release doing? You can be like, right here, dashboard, live. And so you have a bunch of developers. You probably have a big repo. If you don't have a whole lot of code and you have a whole lot of developers, I don't know why you have a whole lot of developers and what's going on. So when you're in a big repo, especially monorepos, you kind of run into some specific problems. And the biggest one that we got complaints at Uber was, hey, why can't we use Kotlin now? Or why can't we use a new Jetpack? Or whatever the new libraries are. And part of that is like, well, we have all this code across multiple apps, and we need to ensure our quality stays good. So yeah, sorry, it did take us 2 years to get Kotlin to GA, but it was for the best. It was to keep things running well and safe, and also making sure that the developer experience didn't suffer, that build times didn't get slow. So yeah, so when you get a bunch of developers, you often are going to have to kind of compromise on the latest Compose beta or whatever. You also need to kind of make sure that productivity is an explicit goal. Ideally, at a certain size, you have dedicated headcount and staffing to making sure developers in this big repo are having a good time or a not horrible time. And having that kind of an explicit goal at a higher level in your organization so that you aren't just bogged down in weird build time problems. Automating away bike shedding problems. So code formatters, anything of that nature is very helpful because if someone's IDE is set wrong and the spacing's off, you don't want their whole pull request to just be littered with spacing changes and then the next person to go back. When you have 100 developers, half the people's IDEs are going to be set to something random. The other thing that starts happening in these big repos is you have to do migrations. So you want to update your library. Well, there's going to be people calling deprecated methods, and you're going to have to deal with that and have a plan. And yeah, getting your libraries updated can be hard. You might run behind on these things. And the hardest one I feel like that I dealt with a bunch at Uber is doing SDK bumps. So bringing in the new SDK every year, making sure we supported that as is, and then doing target SDK updates across the suite of apps. It kind of is slow. So yeah, this is why you should invest in productivity. Make sure that there's headcount for this. Track your build time. Track your continuous integration. Track how long it takes from someone starting coding to it landing in the app and going out the door. Automate your bike shedding. So make lint break the build so that you don't end up with these things halfway in your code and then having to fix them later. Detect, KT lint, spotless. These all kind of minimize your noise and make these things handled by machines so that your developers don't have to think about it. Share your IDE configuration if you can. Even just getting your imports consistent so that if you need to rename a class, you can just do a grep instead of having to muck around in a structural find replace in your IDE. Conformance testing is something that we had at Google 3. And we had a suite of libraries that were not mandatory to use but made your life easier. And we said, in exchange for us writing these and you using them, we want to be able to run these tests over your code to make sure that you are using it right. And we would say, for example, you couldn't mock certain things, or you couldn't use known broken Android classes and pass them forward into these. And if you write an IDE plugin, you can catch these as someone writes the code, so they don't even have to push it up to CI to know it's going to fail. And Yeah, in these big repos, continuous delivery and integration are basically mandatory. You need to be automating your builds, automating your CI, running your tests, preferably every single commit, just because otherwise you're going to end up in a broken state all the time, and I'm going to go to work, pull the new code, and it's not going to compile. So yeah, catch these issues with automation. That way, you don't have to do it. Here's a flow on kind of a way to work on your releases and kind of like the types of builds you can do to automate this flow and automate review, make it easier to do for different stakeholders. And I am speeding up here because I know I'm running out of time. Yeah, you're automating your build pipeline, makes it so that ideally your QA can just download an APK, run it on the device. Even a non-technical user or your designers, your product manager can view your live running app even. Google has a way where you can say, at this, as part of the code review, please launch an emulator of the app at this exact version. That way your designer can poke around and be like, hey, can you just adjust these dips before you commit? And then you can make sure all employees get nightly or weekly builds. Even before, before the customers get it, some companies will make it past QA first. Some companies will just be like, yeah, if you're an engineer, you get the latest brokenness. And then a huge benefit of having a good pipeline is if you do something tooling-wise, so Kotlin upgrade, mess with Gradle, you will hopefully catch it before you go to push to the Play Store and try and build that release build with ProGuard, and then it breaks. That's always sad when that happens. And a ton of users, I kind of went through a lot of these. Challenge of having a ton of users, you need to handle that long tail. So the weird devices, the rare crashes, anything that happens and only to a small amount of users, obscure screens in your app, maybe you have a help screen. That's real important if the user goes to it, but a small amount of users go there. You need to make sure that that is being checked regularly as part of QA or monitored at least. Logging solves you here. So if you have a bunch of users, it's always better to log early and often, so that way you have it when you run into these weird obscure crashes on a device that you don't have access to. Logs are free. It's strings. You can send them up. Firebase handles it nicely. Wherever you try catch, logging's good. And log your exceptions even if you handle them, because that way when you hear a report that something's going wrong and you're like, oh, we're swallowing the exception and not crashing, but doing something weird. And Firebase is great for this stuff. The Crashlytics, it brings in your analytics events, it brings in your logs, gives you one view, so when you have a crash, you can kind of see what the user was doing before the crash. And yeah, make sure that you have visibility into these things before you need it. It's better to log this stuff and keep track of it and then have a crash and have it all right there than have a major crash and all you have is a stack trace. And maybe you don't even know how the user is getting there. And yeah, NDK throws in a whole other thing, another level of fun here. And you will also have old devices, and maybe you just have to say, hey, we're dropping support for, you're raising your min SDK because you're seeing a high level of crashes on these old devices, and it may not be worth fixing. That is okay when you have this many users. It happens. Some fun cheat codes here to get out of these weird situations is forcing an APK upgrade. So there's an official Google library that will put a little banner up. Some companies just like a soft nag, so if they notice that someone's using an old app, they put a little banner up. You can just turn off distribution to devices that you know are really broken. So you can go in the Play console and say, this specific Xiaomi phone running this old version, I just don't want it installed there. At Uber, we had a whole side channel system for recovering from bad state. So if the app crashed a certain amount of times, we'd start clearing certain bits of data in an attempt to maybe fix it. And then the worst case scenario is we'd fail back to a web view of the mobile site so that, with your login token at least, so that you could kind of use it. You could feature flag people off and just say, hey, for these devices, we're just going to turn off this whole suite of features because we know it's not a good experience. And the one thing that I've considered at more than one company more than once is we're like, can we just buy these users some new phones instead of worrying about this? Especially when you're like, hey, there's like 10 users, and our engineering time costs this, or we could spend $1,000 and just get them all new phones. So yeah, in conclusion, and these slides are going to be online, I'll tweet the link out later so you can go through the details, is that these ideas are useful in small teams with small apps. It's just kind of pick and choose where you think you have problems or where you think you're close to having problems. And also, though, make sure that you aren't making development hard. If you care about iteration speed, maybe some of these things are not helpful yet. Pick your pain points, fix those early. But I always say, no matter what, you should have some monitoring in there, just because that's one that is always helpful to have later. And there we go.